Hello everyone, I am Punakirtipiyal. Welcome to LangChain tutorial from Python to GenAI. In this series, we will learn how to move from Python fundamentals to building real-world generative AI applications using LangChain. We will explore key concepts like agents, chains, memory, and model integration, everything you need to start building intelligent AI systems step by step. So let's dive in and start today's session. Today's topic is creating embeddings with Ollama. Let's run open source LLMs locally, no API needed. So let's start with introduction. In this lesson, we will explore embedding techniques using open source models. In earlier sessions, we learned how to create embeddings using OpenAI's API where text or documents are converted into vectors, numerical representations that machines can understand. However, what if you don't want to rely on paid APIs or cloud access? That's where open source alternatives like Ollama come in. We will learn what Ollama is and how to install it, how to use it with open source models such as Llama, Pi, Mistral, and Gamma, how to create embeddings using these models locally, a quick demo of generating and comparing embeddings. So first understand what is Ollama. Ollama is a platform that allows you to run large language models locally on your own computer. It supports popular open source models like Llama 2, Llama 3, PHI 3 Mini, Microsoft, Gamma, Mistral. You can use Ollama to download models directly to your computer, run them for chat, text generation, or embeddings. Avoid dependency on external APIs like OpenAI. Essentially, Ollama acts like local model runner for LLMs. Simple to install, open source, and free to use. So, how to do that on installing Ollama? Visit the official site ollama.com. Let's visit. So, when I click, I will get download. When we download, we will get download file, and that download file, when we double click in Windows, what we have to, you have to double click, follow the simple steps, keep clicking next and finish. Once installed, Ollama runs automatically in the background. You will notice Ollama icon. In Mac OS, if you want to download DMG package, you can download and double click and install. Once it is installed, you can see Ollama like this. So gamma 4, you have a lot of models like this, 12b, 4b, gamma 3, gamma 4, and all. So I can ask hi also. So when I tell hi, automatically it will talk to gamma 3, 4b model and it will answer. Okay, let's see how to talk that one, how to run and all. Okay, now we have gamma. So hi there, it's nice to hear from you again. Is there anything you're thinking about? All questions it is giving. Okay, in this way we can install and we can use the Ollama. Running your first model. Now that Ollama is installed, let's try running a model from command prompt. How to do? Run gamma model. So I want to run this gamma model. So what I will do, I will run this. See, I already installed this Ollama run gamma 2b. So that's why it is searching. Now we are able to ask any question. So who are you? If I ask question, who are you? So it is responding. I am large language model and all answers we are getting. So in previously I already downloaded. That's why we are getting like this. If you don't download this, when you run this first time, it will download Ollama, a gamma model with 3 GB or 4 GB of size, and then it will start to answer question with ChatGPT. Okay, if the model is not downloaded yet, Ollama will pull the model, download it from the internet, store it locally, then automatically start the chatbot. The first download may take time. For example, the Gamma 2B model is around 1.4 GB. Once download, you can chat directly in your terminal like hi, how are you, and all this we did. You can repeat this with any model such as Ollama, Run, Llama 3, Mistral, and PH3 Mean. So we did that one. Now setting up for embeddings. Now till now we come to know how to download Ollama and install that one, how to handle this one. Now we can start with creating embeddings using Ollama models. Ollama models means it is an resources of model. So we can use that one and we can download. Now let's see how to use Ollama models for embeddings in Python. Embeddings are useful in retrieval augmented generation system They help represent text as vectors that capture meaning and similarity. Let's install required libraries. In my So I have already LangChain community, also ChromaDB here. Okay, now what I will do, I will install. So first I will source, uh, bin. I will activate virtual environment, then pip install -r requirement. So when I run, so it will start installing all the requirements. So as of now, all the requirements are satisfied. Now what we need to do? Import the embedding class. Okay, this is my embedding LangChain community dot embeddings. Import Ollama embeddings. I will copy this one. Then what I will do, I will create a new file, Python file. I will import this. Then I will say Ollama embeddings demo. Now my code is ready. I imported that Ollama embeddings. Once it is done, creating embeddings in code. Okay, so to create initialize the first step, initialize the embedding model. So embedding model, what I will do, embedding. So I will load. We know our model is gamma model with 2b. Okay, so embedding we are getting. Then step 2 is embed sample text. So I will take this text. So my example is text. Okay, what I will do, I will print text, then text. So automatically it will print that one. So this is the text. Once that embedding, this is the model, embedding model initials dot embed documents. We are passing the text here. Once we passed, what we will get, print generated embeddings. What I will do, comma vectors, I will print. Okay, let's run and see what happens. What we need to do, Python Ollama embeddings demo. We are running. First it will take text loaded, then text and embeddings are generated for this data whichever we gave. So first letter, second letter of the Greek text, this is our embeddings. Now vectors will contain two sets of numbers, each represent one sentence as a to this 2048 dimensional vector. Next, embed a query. Okay, so what we can go, we are getting a query. So we created vectors, then embed a query. This is my query. Okay, what I will do, I will print query. So this is my query. Then query to be embedded is, that is the query. Next, I will create query vector. So generate query embedding, that is also done. Now what we are doing, when we run, so embeddings for this also generated. We are getting so many queries and generated. Now we are able to see. By comparing the cosine similarity between the vectors, we will see the query vector is close to 1 for sentence about beta. That's how embeddings help find related meanings. So now we generated embeddings for query vector, also vectors. Now what we need to do, perform a similarity search to find whether these vectors we created are properly generated or not. So now what I will do, in this step we will create a chroma vector database from our text embeddings and then use it to find which text is most similar to our query. So what I will do, what is that my query I have? Query I have is, okay, what I will do, I will generate an embeddings. I will, this query sector also I will not print. So query to be embedded and what question we will get. Okay, now what I will do, I imported the vector store from chroma. Now db chroma dot from text, this is my data, then this is my embedding we are passing. Now what we will do, we will save that one. Now db dot similarity search, what is my query, this is my query, and k is equal to 1. We will learn that one, what we are going to do. So chroma dot from text to this one, this line creates a chroma database and stores the vector representation of your text. Each text string is converted into numeric vector using the embedding model Ollama embeddings in your case. These vectors capture the meaning of the sentences, not just the words. So result is equal to db similarity search, query is equal to 1. What it will do? Here we ask the database to find the most similar text to our query. The question we want to find a related text for. K is equal to tells Chroma to return the top one closest match. I don't want other thing. Internally, Chroma uses cosine similarity to measure how close the query vector is to each stored text vector. Let's print the result. How to print the result? This is my result. So what we are going to do? Results. Then clear. Now when I print, so it created vectors, and query to embedded is what is the second letter of the Greek alphabet. Beta is the second letter of the Greek alphabet. So from list of text we embedded, related query we executed, and we got the related output using Ollama embeddings. So this extracts and prints only text content of the top matching result. In this case, it should print something like this. It is printed. So this is all about Ollama embeddings with one model, gamma model we did. Now we can understand exploring other embedding models. Ollama supports multiple embedding models, not just those for chat. For example, MX may embed large, Nomic embed text, all mini LLM. So you can download any of with Ollama pull. We did have large like this. After downloading, update your code with model. Then embed your text as before. The process stays the same. Then practical example recap. Here's the quick summary of how everything fits together. We installed Ollama, download the app and run it locally. Pull a model, for example, Ollama pull gamma 2b. Install LangChain libraries, pip install LangChain community. Use Python to generate embeddings. We did that one. So compare embedding, use them for semantic search, RAG or similarity matching. We did this one. This was practical example, whatever recap we did. Next, wrap up. In this lesson, you learned what Ollama is and why it is useful for local model deployment, how to install and run open source LLMs on your own system, how to create embeddings using Ollama and LangChain, how to experiment with different models for better accuracy or speed. Ollama makes it easy to explore embeddings without relying on APIs like OpenAI, giving you full control over your data and models. Let's quick recap for video outro. So by the end of this session, you will be able to install and set up Ollama on your computer. Run Llama, Gamma locally. Use these models to generate embeddings. Understand how embeddings represent text meaning as numbers. In upcoming videos, we will use these embeddings to build RAG-based applications, search systems, and chatbots powered by local models. So thanks for watching today's session. This was part of LangChain tutorial from Python to GenAI. If you found it helpful, please subscribe to my channel for more lessons on building with LangChain and Generative AI. Also, feel free to connect with me on LinkedIn. You will find the link in the description. See you in the next session. Thank you very much.